We talked about wheat in the last podcast in the context of fungal diseases, and we mentioned the International Plant Protection Commission or Committee, IPPC, and how it should get similar awareness as the World Health Organization. Here we are moving forward using the word pandemic for a disease that's been affecting wheat across the planet. So this is a paper. I used the image in the thumbnail that comes up for the link. I love these genetic paper links that they use to see the origin and the spread of the genes across various hosts and so on. Genomic surveillance uncovers a pandemic clonal lineage of the wheat blast fungus. I'll just read the abstract, literally 1 minute, because this is paper is about details of genetic analysis to figure out a few things and suggesting how the wheat blast disease pandemic may be mitigated, if not controlled, with the genetic techniques. Wheat, one of the most important food crops, is threatened by a blast disease pandemic. Here we show that a clonal lineage of wheat blast fungus recently spread to Asia and Africa following two independent introductions from South America. So basically the gene got cloned and got introduced into two places and made the pandemic worse. They have a map about how it's where all it exists, but that comes with genetic information that I didn't want to get into. Through a combination of genome analysis and laboratory experiments, we show that a decade-old blast pandemic lineage can be controlled by RMG8 disease resistance gene. So we're talking about genetic modifications, and is sensitive to strobilurin fungicides. However, we also highlight the potential of the pandemic clone to evolve fungicide insensitive variants and sexually recombine with African lineages. So you can see cloning and sexual recombinations are different. So cloning is where you're just multiplying, and this can multiply and become abundant very fast, whereas sexual recombinations are slower, but they are better for capturing the beneficial mutations and getting rid of the harmful mutations, and that's the most prevalent sexual reproduction pathway. But still, this underscores the urgent need for genomic surveillance to track and mitigate the spread of wheat blast outside of South America and to guide preemptive wheat breeding for blast resistance. Okay, that's the crux of the paper. There are many details provided, but I'm just going to leave it here. I just wanted you to point to you to the paper and let you follow up if you're a genetics kind of person or interested in more details of this research. Okay.